Hi, this is Chris Sorel. I'm the AI Advisory Practice Lead at Catalyte, and today I'd like to spend a few minutes talking with you about ethics and risk in AI systems. Okay, so I think the first question we have to ask is why are AI systems so risky? Why is this such an important conversation when we talk about AI? And I think the best way to frame that is that it's a difference of deterministic systems versus probabilistic systems. So in traditional software engineering, we have deterministic systems. And what I mean by that is if we write a method that accepts two numbers and returns the sum of those numbers, and we provide 1 and 2, we're always going to get 3. We can't get anything but 3 because it's a deterministic system. And so we can say that if coded correctly, an algorithm will always return the same output for a given input. And this is something we have 100% confidence about. It's testable. We can write unit tests around it. We can automate it. And we largely don't have to ever think about that again once we've written it. On the other hand, if we contrast that with probabilistic systems, and by that I mean AI systems, they're largely concerned with inferring meaning or intent. And so what they will do is return something of a confidence score. For example, if I ask a generative AI system, what can I make as a carpenter? It has to decide, do I mean what could I build physically as a carpenter, or what could I earn as a carpenter? And so it might return back a result saying, I'm 80% confident that he meant what can he earn as a carpenter. And so we as implementers have to decide what our level of comfort is with 80%, or what if it's 60%? And what if it comes back with a high confidence but it's incorrect, and how do we handle that? And so this is a core concern, is that we can't always be 100% confident that the result is accurate. And moreover, in some instances, an AI system for a given input could return a completely different result. And so this is confounding, because we have to design tests and we have to find ways to ensure that the system is reliable and accurate. And that uncertainty really introduces risk. And so as engineers, as business leaders, we have to determine how do we handle that risk? What can we do to identify and manage it? So the way that we've landed in the industry in terms of trying to answer that question is to adopt ethical principles for AI. And so when we talk about ethics in AI, we're talking about a set of principles and guidelines that can help to identify and mitigate the risks inherent in probabilistic systems. And, ethics is certainly a kind of a loaded term, but when we talk about it in regards to AI, it's really a utilitarian concern, meaning that it's interested in optimizing the good, or the ROI, that the system produces, while minimizing the harm or the risk that it could inflict. And we've generally kind of landed on a consensus that organizations that implement AI systems have an obligation to mitigate these risks. The cost savings, opportunity, and competitive advantage gained from using AI doesn't justify ignoring these risks. And we can't hide behind the AI and say, well, it was the system that caused the problem, because ultimately we're the ones that produced and deployed the system, and it is operating on our behalf. Industry, government, and NGOs have largely coalesced around a core set of ethical use principles for AI. Different organizations may have slightly different names or descriptions, but they're all largely pointing at the same concerns. The first one is fairness. So AI systems should treat all individuals equitably, avoiding biases that could lead to discriminatory outcomes. Consider an AI system that's responsible for pre-screening mortgage applications. If that were to consider race or gender or their name or socioeconomic status in some way that's not relevant to qualifying for a mortgage, that would be fundamentally unfair, but it also could be legally actionable. And the challenge here is that these biases are often introduced through implicit bias in the data upon which the model is trained. And so if your data has bias, then of course your AI system is going to have it as well. And so it's critical that you identify those biases and have processes and policies and engineering approaches to mitigate that. Next, we have inclusiveness. So AI should consider and include all people regardless of their differences. Obviously, race, ethnicity, gender identity, ability or disability. Our differences, of course, can have impact on how systems treat us and potentially be disadvantageous to us. So consider at a minimum, having a screen reader capability for your AI chatbot, is a good example of how we can be inclusive of people who have some disabilities. And so, what we're driving at here is that AI should convey the same advantage and be at the same amount of availability and accessibility for everybody, regardless of their differences, and it should largely be agnostic to those differences. Then we have reliability and safety. So AI systems should reliably operate in accordance with their intended purpose. Reliably in the sense that they should always do the same thing, and they should only be able to function within the narrow scope of their intended purpose. So we've seen examples of organizations spinning up a chat GPT based chatbot on their retail website and people figuring that out and using it to generate essays about Shakespeare and stuff like that. And that's clearly outside the intended purpose. So it's important that systems be engineered with guardrails so that it only functions within the scope of its purpose. And then they should not pose unreasonable safety risks. So a retail chatbot probably is not providing a lot of a safety risk, but consider a chatbot that offers information about medication interactions, or a AI system that's responsible for routing rail cars in a rail yard. Those are systems that have the potential to cause grievous harm to life and property. And so, that's a much greater safety risk. And the effort that you put into managing and mitigating those safety risks must be commensurate with the safety risk at hand. And so your effort needs to be equally comprehensive to mitigate that. Then we have privacy and security. So AI tools must respect user privacy and personal data. Now, there's some contention there, of course, because organizations typically want to collect as much information about users as they can, and users typically want to protect that information from collection as much as they can. But an AI system ought to have a readily available privacy policy, and it ought to function within the bounds of that privacy policy so that people know what to expect. And then AI systems should ensure the security of data. And so if you consider Microsoft Copilot 365, it applies the same permissions to the content that it generates as were available or were applied to the content that it sourced from. So if you had a document, if you didn't have access to a document in a SharePoint library, you wouldn't have access to content generated from that in Copilot. And so that's an example of ensuring the security of data. Other systems, will have to consider that as well. Should, for example, a retail chatbot have access to your financials data? Well, of course not. Nobody should be able to ask the chatbot to summarize your quarterly earnings from your public website. And then systems should build in resilience to minimize the potential for adversarial influence. And so resilience in the sense that it shouldn't be able to be manipulated or use prompt engineering to get elevated privileges. And it should also be resilient in the sense that it can't be brought down by denial of service attacks or put into a state where an attacker has elevated privileges or access to information they shouldn't. Then we have transparency. So AI systems should provide clarity about how those systems work, how they make decisions, and how they learn over time. So I should be able to go to a generative AI chatbot and say, how did you come to this conclusion? And it ought to be able to tell me what information it used to derive that conclusion and content, provide references, and provide information about any decisions that it made in the process. And the worst thing you could have here is a black box where nobody knows what data was used to produce a result. Nobody knows the conditions that could replicate it. And as such, you really can't remediate it. And that leads us into accountability. Of course, organizations and individuals should be accountable for the actions of the AI systems they implement throughout the life cycle of those systems. And we've seen courts uphold that AI systems are acting as agents on behalf of the organization that produced them. And we saw that with Air Canada, where they had a chatbot that offered a discount that didn't exist, and the courts upheld that it was a binding contract. So it's important that at the end of the day, there is somebody who is accountable for that, and legally and otherwise. And having skin in the game in that way means that people are going to be more diligent, and organizations are going to be more diligent in ensuring that their systems are applying all of these ethical use principles. So that's been a brief overview of ethics and risk management in AI systems. In subsequent conversations, we'll talk a little bit about how we can leverage risk management frameworks and other best practices to apply governance and policy and engineering practices to apply these principles into real world situations. Again, this is Chris Sorel, AI Advisory Practice Lead at Catalyte. You can check us out on our website at catalyte.io. We have an AI readiness assessment you can take, some white papers you can download, as well as further information about our services. Thank you so much for your time. I hope you found this presentation informative and enjoyable, and have a great day.